Hello students, today we will discuss a new device that is called potentiometer. But before discussing the potentiometer, we will focus on voltmeter. A voltmeter is a device that measures potential difference. But an ideal voltmeter which does not change the original potential difference needs to have infinite resistance. Since we don't have a ideal voltmeter or a voltmeter of infinite resistance, it means the potential difference measured by voltmeter is not accurate. Now, potentiometer is such device which does not draw any current from the circuit and still measures potential difference, so it acts like an ideal voltmeter. So we can say that potentiometer is a device that measures EMF or potential difference accurately. Now let us see the working of potentiometer. So let us see the diagram for potentiometer. So a potentiometer contains a battery. This battery is called driver cell, and key over here we can connect a rheostat for controlling the current in the circuit. So I have a battery, a switch, a rheostat to control the current, and let the EMF of this battery is even. We can also take a cell. So this is a battery, and let me call these 2 points as AB. This is called driver circuit or primary circuit. Now I will connect a wire to these two terminals, and since the wire taken is long, so I will fold it. I will explain you why a long wire is taken in that process. So this is a wire, AB wire. Since it is long, so I have just folded it, and this is the primary circuit of the potentiometer. Now before going through the working of potentiometer, first of all we will discuss the principle of potentiometer. So the principle of potentiometer says that if current in the wire is constant, so if we need potential difference across any resistance R, so we know that from Ohm's law we can write V is equal to IR, and R can be written as rho L by A, where L is the length of the wire. Since I told you that resistance is a resistance of this wire, and here I am taking the L length of this wire, so it is the resistance of that part. Now if your I is constant, then resistivity will not change, area of the cross section will remain constant, and if these parameters are constant, we can write that potential drop is directly proportional to the length of the wire, and that is the principle of potentiometer, that when steady current flows through the wire, then potential drop is directly proportional to the length of the wire. And let us understand this in a very simple way. For an example, suppose I am having a wire of 10 meter, and when I is constant, then voltage drop across this is 10 volt. So this says that V is directly proportional to L. It means if I will take 1 meter length, the potential drop will be 1 volt. If I will double the length, 2 meter, the total potential drop will be 2 volt. If I will triple the length, the potential drop will be 3 volt. And if I will take the complete 10 length, I will get a potential drop of 10 volt. But it is true when current in the circuit is constant. So as well you increase L, the potential drop will also increase, and that is the working principle of this potentiometer. So I hope it is clear to you. Now just look at one case, and the case is Current flows due to the potential difference, everyone knows. For an example, say I have a battery of 4 volt here and a resistance is connected, and another battery of 3 volt is here with a resistance of say 1 ohm and 2 ohm. Now the current will flow in the circuit because there is a potential difference between these two terminals, and you can say that because of these potential difference the current will flow in the circuit. The 4 volt battery is powerful, so it will drive the current in the circuit. On the other hand, if I will replace the batteries, this will be 4 volt, this is 3 volt, then now my 4 volt battery is powerful because the potential drop here is strong in the bottom part, so this battery will drive the current in the circuit. So if two batteries are connected, then the more powerful battery drives the circuit. That is the concept. But what will happen if this battery is also of 3 volt? If I will make this battery of 3 volt, then these two cells are connected with the positive terminals from the one wire. So the same amount of current will flow from these two, and when the same current will come and counter, then from Kirchhoff's first law, the net current must be 0. So if there is no potential difference, then the current will not flow, and if I will add a galvanometer in that circuit, then it will show 0 deflection, and that concept is very important in potentiometer, because if current is 0, then it is only possible when the potential difference across two terminals or 2 points is 0. So now let us take my potentiometer. So suppose that this wire AB has a potential difference of V across it, because this battery will drive the current in the circuit. So as this wire has some resistance, so that there will be a potential drop across it, and consider that LAB is the length of this wire. So if I will divide the voltage across the battery to the length of the wire, it is the voltage drop across the wire, it is the length of the wire that I have connected, then this ratio is called K, and that is called potential gradient. And if current is constant, then this potential gradient remains constant. So for constant current, the potential gradient, that is the potential drop per unit length, and its unit will be volt per meter, that remains constant because the current from this battery is constant. So remember that this is the potential gradient. Now if I will connect a battery of unknown EMF here with the help of a galvanometer, say, and the EMF of this cell is say E2, and what we will do, we will touch this wire with the help of a jockey. I told you, jockey, it is a whitener shaped device that is used to connect. So cell is connected with the help of galvanometer, one end of galvanometer is connected to jockey, and if I will touch the jockey on this wire, then there will be a point on this wire where this galvanometer will show 0 deflection. But the important thing is, to work this process, your driver cell's EMF, that is E1, must be greater than the potential drop across the wire. This is a very important condition for the working of the potentiometer, that if you want a null point is the point where galvanometer shows 0 deflection, the EMF of the driver cell must be greater than the drop of the potential across this wire. So there will be a point where the galvanometer will show 0 deflection, and that means the potentiometer or this galvanometer is not drawing any current from the circuit. And as I told you that if there is a 0 current here, it means the potential drop here and the potential drop across the wire must be equal, such that the current is 0, because it is required. So consider that this is the point and this length is the balancing length. Balancing length means the length at which galvanometer shows zero deflection. So we know that K is the potential gradient. It means it tells the voltage drop per unit length. So now we will apply the concept unitary method, and unitary method says that if K is the voltage drop per unit length, then we have L length. So K is the voltage potential drop in unit length, and in L length the potential drop will be KL. So first, if you know K, if you know the balancing length, you can easily find out the potential drop across the part of this wire, and that must be equal to the EMF of the unknown battery. So I can also write it as E2 equals to KL, and by this way we can find out the EMF of the unknown battery. So this is the potentiometer working. So first of all, what we need to understand that what is K. So for K, you have to divide the voltage drop across wire with the length of the wire, and the second is to find the balancing length. It means the point or the length at which the galvanometer shows zero deflection. Now we will discuss some applications of potentiometer, and the first application is the comparison of EMF of two cells, and that is practical in the 12th class also. So just understand it. So I want to compare the EMF of two cells, and the EMF of both the cells are not known to me. I only need to compare the EMF. It means I need the ratio of the EMF. So for that, I will first make the primary circuit, and that is the driver circuit with switch, with rheostat, and this is my primary circuit. So this is A point, this is B point, and this battery is E. Now I will connect the wire. This is the wire AB, and remember that when it is the positive terminal, so the battery terminal of the unknown cell must be connected in such a way that at this terminal the positive terminals are connected. If you will not make the circuit like this, the current in the external circuit will never be zero. The galvanometer will never show zero deflection. So just make sure that when you are connecting batteries, the positive terminal must connected at the single point. So this is my first battery, like E1 EMF, that is unknown, and this is my E2 battery. The EMF is unknown. These are two cells or the batteries, and this is a three-way key. I will connect it with the help of galvanometer and jockey. Now first of all, I will connect E1 cell with this terminal with the help of keys. So when I will connect this terminal to the galvanometer branch, my cell E1 will be effective, and I will touch the wire on this whole wire to find out the null point, and suppose that this is P point where this galvanometer shows zero deflection under the action of this E1 cell. So I tell you that if say L1 is the length of this wire at which the galvanometer shows zero deflection, so I can write that E1 is K times L1, where you know what is K. K is the potential gradient, and that can be calculated by dividing the voltage drop across complete wire to the length of the wire, or I will write it here. This is voltage drop across the wire to the total. So you can calculate L, and when you will multiply the balancing length with K, you will get the EMF of this cell, and this is my equation number 1. Now I will remove this connection and I will connect E2 battery with this. Now remember that if this E2 is greater than the EMF of this cell, because the EMF are unknown, you don't know, but suppose that E2 is greater than E1, in that case the balancing length will increase. It means you will get the null point at a larger distance from this point if battery EMF is more than E1. On the other hand, if the EMF of this E2 is less than E1, in that case you will get the null point at a short distance. It is a way to identify that which one of these two cells is with high EMF. So the cell that gives the balancing length at large distance has high EMF. So consider that in that case the balancing length, like this is L2, this is the distance from here to here for the E2. So for E2 I can write K times L2. As I told you that K will not change. K is decided by this battery and this is constant, so K will remain constant. So we have L1 and L2. Remember that if E2 is greater than E1, L2 will be greater than L1. If E1 is greater than E2, then L1 length, the balancing length, will be greater than L2. Now I will divide these two, and since K is same, the EMF ratio will be L1 by L2. So by dividing the balancing length, you can easily compare the EMF. Now once again, if your E1 is greater than E2, then L1 by L2, or the ratio will be greater than 1. If E1 is less than E2, then the ratio will be less than 1. Now we will discuss the second application of potentiometer, and that is to find the internal resistance of the cell. So we have to find out the internal resistance, as we have discussed that each cell is having some internal resistance. So in that case we will find the internal resistance of the cell using the principle of potentiometer. So for that, first of all we will make the primary circuit or the driving circuit like before. Switch, rheostat and these two terminals. Now I will connect the wire from these two terminals. It is a long wire. Now I will connect the cell. So before connecting the cell, just keep it in mind that this is the positive terminal. So the positive terminal of the cell must be here. So this is my cell, and I will connect a resistance box in parallel to this cell with the help of one key, and once again galvanometer, and this is with jockey. First of all, let E1, E is the EMF of this cell, and let me call this EMF as E1. So first of all I will remain this key, let me call this key as K1 open. Open means this branch is not functioning, or you can say that this circuit is not complete when key 1 is open. So my cell E1 is only effective, and let in that case the balancing length is L. When you are using only cell E1, resistance box is not functioning. So we know that if balancing length is L, then I can find out the EMF as KL1. Say this is L1, because you know that voltage drop across these and this end of wire is same as EMF of the cell. We have already discussed it. Now if I will make the key K1 closed, so if K1 is closed, in that case, suppose R is the resistance that is applied in the resistance box. So now in that case the resistance will start functioning, and you will not get the EMF, you will get the terminal potential difference across this cell. Since it is another circuit, the resistance box and internal resistance both will drop some potential, and you will not get the EMF. In fact, you will get the potential difference or terminal potential difference across this wire, and let terminal potential difference is V. So if Q1 is closed, as I told you that this E will be less, as you know that the terminal potential difference across the cell is always less than the EMF of the cell. So if EMF is less or terminal potential difference is less, so you will get the balancing length at less distance than before, and say this length is L2. So for this L2, let L2 is balancing length. So for this L2, I can write V as KL2. And remember that this L2 must be less than L1, because in that case, this is not the EMF working, this is the terminal potential difference across the cell that is working. So I will divide these two and I will get E by V as L1 by L2. Now we have a formula of internal resistance with external resistance that we have discussed before, and that was that internal resistance R and external resistance R is connected with the EMF and the terminal potential difference like this. So I will use the value of E by V here, and I will get small r, that is the internal resistance, is external resistance that is applied through resistance box, and this is L1 by L2 minus 1. So once L1 is the length when resistance is not functioning, when resistance from the resistance box is functioning, then the balancing length is L2. R is the resistance that we have applied, so you know the values of L1, L2 and R, and by this formula we can easily calculate the internal resistance of this cell that is connected. Now we will discuss a very important term that is related to potentiometer, and that is the sensitivity of potentiometer. A potentiometer is said to be more sensitive if it is capable of measuring a very small potential difference, and it shows significant change in the balancing length for a small change in the potential difference being measured. So these are the two basic properties for a potentiometer to be sensitive. The sensitivity of the potentiometer depends on the potential gradient, that is K. Smaller is the potential gradient, greater will be the sensitivity of the potentiometer, and as we know that potential gradient is given by voltage drop across the wire to the length of the wire. So to minimize this K, we can increase L. So if you will increase the length of the wire, the K will be small, and once the potential gradient will be small, the sensitivity of the potentiometer will increase, and that is why we were taking a very long wire in the potentiometer. In the laboratory, almost 10-meter wire is used in the potentiometer. So if you will increase the length of the wire, it will increase the sensitivity of potentiometer. But there is one important thing from this formula, that if you have VAB fixed, then by increasing the length you can increase the sensitivity because K will decrease. In some cases, special cases, the length is fixed. So if length of the wire is fixed and you still want to increase the sensitivity, then you have to decrease the value of current in the circuit with the help of rheostat in the primary circuit. So if you will decrease the value of current, the voltage drop across the wire will decrease, and it will decrease potential gradient and the sensitivity will increase. So if you have constant current, then you have to increase the length of the potentiometer to increase the sensitivity of the potentiometer, and if you have a fixed length potentiometer, then to increase the sensitivity of potentiometer you need to decrease the current in the circuit. So these are the two different cases when you can increase the sensitivity of the potentiometer, but in general the current in the circuit remains constant, I told you. Then by increasing the length, the sensitivity of the potentiometer will increase.